Hello, here we are with another A-level maths video. This one is on statistics, the year 1 content. We're working through chapter 2 and we're looking at section 2.3 of the textbook here, where we're going to introduce ourselves to some measures of spread. Now, we've done quite a bit of work in the past couple of videos on measures of location, and that means, of course, that when we're looking at things like means and medians, we're looking for a number which in some way represents a typical number from that set of data. But of course, the set of data isn't just one number. It's not just a typical number. There's going to be some variation around that number, whichever measure of location we choose to use there. And so it's often a very useful thing for us to do is to work out how much variation, or have a measure of how much variation there is. And that's what we call a measure of spread. The definition on the screen there says that a measure of spread is a value that gives an indication of the spread or variation within a set of data. And there's one measure of spread which I'm sure you're already familiar with from your previous studies. The range of a set of data, which is defined as the difference between the largest and smallest values, that's a measure of spread. It's a number which gives us an idea about how much variation or spread there is in our set of data. So in a second, I'd like you to pause the video and just quickly calculate the range of the set of data on this screen there. Okay, let's have a look. So our range is the biggest number in our set, which in this particular case is 414. Subtract the smallest number in our set, which in this case is 66. And the answer we get when we do that, you should have got 348. So that means all of our data in our set kind of falls within a band which has a width of 348 along our number line. Now, I want you to think a little bit about, whether or not this is a good measure of spread. I mean, it's good in the sense that it's very easy to calculate, but look at the data set we've got there. That 414, which was the biggest number in our set of data, is actually a very unusual very unusual item of data. Compared to the other numbers, it's much, much, much larger. So one disadvantage of the range is that it's very sensitive to these very, very unusual values here. And for that reason, we might want to look at some slightly more sophisticated measures of spread. So here's another measure of spread which you may have seen before. It's called the interquartile range. Now this is what we get when we work out the two quartiles of our set of data and then we subtract one from the other. And the reason why this might be a better measure of spread to use in lots of situations is it's not as sensitive to those very unusual extreme items of data which we sometimes get. Anyway, pause the video in a second. Please see if you can remember how to work out where those upper and lower quartiles are, and then calculate the interquartile range. Okay then, so let's see if we can do this. Now, do you remember how we do this from just a list of numbers? First of all, we need to know how many there are. Now, there are 11 numbers in our set. So to find the position of, let's do the lower quartile first. We need to work out 25% of 11, and that turns out to be 2.75. And remember the rule, if this is not an integer, we round up. So it must mean that our lower quartile is in the third position in our set of data. And so therefore, looking at the data itself, that must be the number 79. That's the first, second, third number in our set of data is 79. Let's work out the upper quartile using the similar method. So the first thing we do, work out 75% of the 11 items of data we've got there. That turns out to be 8.25. And again, the rule says we have to round up. So our upper quartile is going to be in the position 9 in our set of data. And that means that we end up with 162, I think, is the 9th number in our position. Okay, hopefully you agree with that. So our interquartile range, I'll just write IQR, is going to be the difference between those two numbers. Upper quartile minus lower quartile, 162 minus 79. And I think that gives us an answer of 83. What does that mean? Well, it means that about a half of our data fits in a band on our number line of width about 83. And that's a good measure of spread because it takes into account the fact that we may have these very extreme values which may distort things, and it's not so distorted by that. Okay, hopefully you got that right. And as I said, I'm expecting that you've seen the idea of interquartile range before. But have you heard of an interpercentile range? Now, we looked in the last video about percentiles of data, and in fact, you can work out measures of spread which are different percentiles as well. I'm going to show you an example of the kind of thing I'm talking about right now. So what we've got here is we've got some data regarding the ages of 300 houses in a particular village. And we're going to use linear interpolation, remember that from the last video, and we're going to use that to estimate the 5th to 95th interpercentile range. So what we need here is we need to, first of all, work out what that 5th percentile is and what that 95th percentile is. I'll do the 5th percentile in full. It's quite a long process, remember, the linear interpolation process. So to find the 5th percentile P5, the first thing I need to do is work out what 5% of 300 is, because we've got 300 items of data. That's going to be the position where our 5th percentile is going to be. And I think that is 15. So which class is the 15th item of data in? Well, actually, the first 36 items of data in between 0 and 20. So we're going to be between 0 and 20. So remember the little picture we drew? We're somewhere between 0 and 20. Our 5th percentile is somewhere in between. I'll put P5 there. Up to 0, of course, we don't have any items of data. And then we have 36 items of data there. We are looking for the 15th, roughly, item of data here. So remember how we set up the equation? We look at the distance from here to here as a proportion of the whole distance from here to here. And it's got to be the same proportion for the numbers on the bottom as it is on the top. So setting that up means the distance from P5 down to 0, P5 minus 0, as a proportion of the whole distance from 20 down to 0, has got to be the same as the proportion from 15 down to 0 here, as a proportion of 36 down to 0 here. Okay, now, if you work out and solve that equation, I'll just tell you what the answer is here. We get 8.33 to 2 decimal places here. So do you remember how that works? Okay, I'm not going to do the whole thing for the 95th percentile as well as that. I'm just going to tell you that the 95th percentile, if you do the same thing, it turns out to be 333.33 to 2 decimal places. So our interpercentile range here is going to be, hold on, let me just do that again, the 95th percentile minus the 5th percentile, which is 333.33 minus 8.33, and we get an answer there that our interpercentile range that we want here is actually the value 325. So do you see how it works? You might need to use interpolation to find the values that we're interested in here, and then subtract one from the other to get that interpercentile range. Okay, here's one for you to have a go at yourself then. There is a situation on the screen there. I'd like you to first of all use linear interpolation to find those appropriate percentiles, and then subtract one from the other to find that interpercentile range. And there's a little follow-up question on the screen for you to have a go at as well. Please make sure you have a go at all of those questions before you restart the video. Okay, so how did you get on here? I'm just going to show you my answer. I won't go through it in a lot of detail, but you can pause the video and study it if you need to. So the first thing that we needed to do was work out that 10th percentile. Here's my working here. So the 10th percentile, I worked out that was going to be in position 20. I set up my little picture here, solved the equation, and I ended up with an answer there of 4.35 when I rounded it to 2 decimal places. So there's my 10th percentile of my data. What about the 90th percentile here? Well, the 90th percentile, I first of all had to work out that was in position 180, and then set up my picture here, got an answer there for P90 of 69.55 rounded to 2 decimal places. Okay, hopefully you agree with that, and if you didn't, then please do pause and go back and check your work and make sure that you are, seeing what's going on with that. So the percentile range that we want, the interpercentile range we want, is going to be P90 minus P10. So that's going to be the 69.55 minus the 4.35, which I believe to 2 decimal places is 65.20. So So there is the particular interpercentile range that we were after here. Okay, so going back to the question, we were asked one other thing here as well, weren't we? We were asked to explain why the interpercentile range might be more useful than the range as a measure of spread. Well, simply that interpercentile range is not anywhere like as sensitive to those extreme values that we might get in a set of data like this. So that's the reason why the interpercentile range might be more useful. And that's the end of the section on these measures of spread. There are more measures of spread we're going to learn about in the next video, in the next section of the book. But for now, please do make sure that you do understand these interquartile ranges, these interpercentile ranges, by having a go at the questions in exercise 2D of the textbook. Okay then, that's it for this video though, and I'll see you again next time.